Can you see my Canvas web page?
Yes.
All right. Normally, you have to go here to access. All right. You have to go through this video right here. 105 Zoom, first day Zoom meeting. Okay. Those who came to the class, joined the class recently, you need to go to this Zoom meeting. Okay. And you can go through the syllabus. I described in the Zoom meeting, first day Zoom meeting, everything about the syllabus and the calendar. So you have to go there. And I started on chapter 1. It's in module 1. Modules are for each test. There's a module. Module 1 covers chapter 1 and chapter 2. So you can look at module 1, chapter 1. Do you have a question? So I already gone over August 15, Zoom meeting 1. There's a recording there. On August 17, there's a second Zoom meeting. I went over chapter 1 material. So I am going to start where I stopped on August 17, and continue from there. Okay? You go to module 1 and check whatever my Zoom meetings. If you miss Zoom meetings, you can watch the videos. All right? So let me go back to chapter 1. Do you have any questions?
How often are we going to meet in a week?
I am going to have a Zoom meeting 2 times a week, Tuesday and Thursday, 1 o'clock. There are other material you can use for studying here, okay? Before we take the test 1, which is on chapter 1 and 2, you have to do quiz 1 and quiz 2. Quiz 1 is right here. Do you see that quiz 1 for chapter 1 and quiz 2 for chapter 2 after we go over chapter 2 material? Then we have a test, last item on the module 1, CHEM 105 test 1. On test 1 is on chapter 1 and 2. After you've taken that, you are done with the one of the tests. So we go to module 2 and do same thing for chapter 3 and 4 and take the test 3 for chapter 3 and 4. All right. So we go roughly about 8 chapters in this course. Okay. Let's do module 1. Get ready for test 1. All right. I want you to do me a favor. Go to chat box and sign up your name. Type your name, first name and the last name. Okay? So do you have any questions? You guys okay? Okay, let me start on chapter 1. Can you see my web page? PowerPoint slide page for chapter 1. Matter, energy, and measurement. Can you see it?
We can see.
Okay, I want to make sure you can hear me. Okay, we go on over chemistry and study of matter. And we also went over scientific method. You need to go back to Zoom meeting 1 and 2 and catch up. We also talk about reporting numbers in science. Where we stop was significant figures in the number. Okay, so we're going to continue from there, making measurements, unit conversions, states of matter, and properties of matter, density, and specific gravity. And we also going to describe the forms of energy. So I not going to do everything again and again. I go over these chemistry of describing the chemistry. Chemistry is study of matter. And we gave examples. I go over certain questions. It's in Zoom meeting 1. Okay. Go back to Zoom meeting 1 and follow this up. And then we went to scientific method, Zoom meeting 1. And questions about scientific method. We also talk about measurement, which is important to scientific method. So measurements are observations. They are qualitative and quantitative. I gone over this in Zoom meeting 1. We also talked about how to express measurements in scientific notation, exponential notation. So you should be able to do that. If you are not sure about it, go through the Zoom meeting 1 and go through the examples I have given. Scientific notation. I go over the examples. No need to repeat the Zoom meeting 1. Now, significant figure is a number that we assign to a measurement. For example, do you see, let me go through this. Significant figure, this is important. Significant figure is how many numbers we think are significant in the measurement. Normally, non-zero digits are always significant. For example, this number 65.2, how many significant digits are there? How many digits are there? 3. Normally, 3 is the answer. When you do a measurement, we don't give a lot of numbers. We round it off to the first decimal place. So significant figure is easy to find out. This number 65.2 has 3 significant digits. This number has how many? 6 significant digits. Zeros does not count as a significant figure when it occurs. Zeros are not counted for significant figure at the beginning of a number. For example, 0.00245. There are 3 zeros at the beginning of the number. They don't count. That means leading zeros are not significant. So those zeros doesn't count. Therefore, significant figure on the measurement is 3. This one, what do you think? It should be 1. Beginning zeros doesn't count. Leading zeros doesn't count. Now this is trailing zeros. Trailing zeros at the end of the number on a whole number doesn't count. 2,570, that zero doesn't count. 3. Now what do you think? Same argument. This should be 2 zeros on the left shouldn't be counted. Therefore, it's 5 significant digits. Now, you got the idea. I gone over this on the up to second Zoom meeting. Now I am going to continue from that. When you add 2 measurements, the answer also has a significant digit. How you get that is based on either if you're doing addition and subtraction, rules are different. If you're doing multiplication and subtraction, rules are different. For addition and subtraction, rules are you find the decimal place, lowest decimal place. Lowest decimal place in these 2 numbers are first decimal place in 3.6. Highest decimal place is 10.11, second decimal place. So first decimal place is the one that added or subtracted numbers should be rounded off. When you do a calculation, you get, when you put that in the calculator and get the answer, you get 6.51. Now this number need to be rounded off to first decimal place. So you go there, drop the 1 in the second decimal place. If the second decimal place was greater than 5, you need to add 1 to first decimal place. In this case, it's less than 1 is less than 5. So answer must be 1 decimal place, rounded off. So answer is 6.5. So this number has 2 significant digits. That's how you get the addition and subtraction significant figure. When you have three numbers added up, 5.63 plus 2.302 plus 3.16. When you put that in the calculator, when you added them up, you get 11.092. So what we said was, calculator answer should be rounded off to lowest decimal place of numbers. The lowest decimal place is second decimal place. 5.63 is to the second decimal place, 3.16 also second. So this number, calculated number, 11.092 should be rounded off to second decimal place. When you round off to the second decimal place, the number to the left is less than 5. Therefore, you just drop it. So answer is C. You drop the 2 and leave it here. This is the answer. So same idea. I'm going to go through this one only. When you add it up, you get 10.884. The lowest decimal place is second decimal place out of all these three numbers. Therefore, it should be rounded off to second decimal place. And you need to drop the 4. 4 is less than 5, so you just drop it. So answer is 10.88, which is C. So it's pretty simple. Same idea, you added problem 57. You added these two numbers, first numbers, and subtracted third number. You can do it in the calculator. So calculated answer is 4.84. It should be rounded off the first decimal place. It should be 4.8. A is the 4.8 is D. Now, it's pretty simple to get the correct answer to calculated answers from measurement. Now, multiplication and division follows different rules. These two numbers are divided. Now you don't look at the decimal places. You look at, for multiplication and division, you look at significant digit. 4 here. 5.5 has 2 significant digits. So answer should have 2 significant digits. Now we are looking at the lowest significant digit, not the lowest decimal place in addition and subtraction. So answer is 63, calculated answer. When you put that in the calculator, you get 63.854545. Now you have to round it off to 3. This is the last number to keep. If you round it off to 63, this has 2 significant digits. Now the number next to 3 is 8. Therefore, you have to add 1 to the 60. 1 to the number 3. So I describe here in detail. Answer becomes 64 when you round it off to the first place. 64 is the answer. So these are the rules that we followed. If the first digit to be dropped is between 0 and 4, drop it and all remaining digits. You drop, including 4 and all the digits to the left. Between 5 and 9, you round up last digit to be retained by adding 1. In this case, 3 is the retained number. So since this is greater than 5, you add a 1 to there. So these are the questions. The calculated answer for this multiplication is 38.5658. So first number, 4.238, has 4 significant digits. And now 9.12. Therefore, this number has need to be rounded off to give 2 significant digits. Since to get 2 significant digits, you have to drop these numbers. The number to the left is 5. It's greater than 5 or greater than 5. Therefore, you need to add a 1 to the 8. Answer becomes 39. The answer is D. So multiplication and division follows significant figures, not the decimal places, lowest decimal place. So this is similar question. This number need to be rounded off to 3 significant digits. How do you get 3 significant figures from 4.2375? You have to round it off to that 23. Rounded off to 3 here. So this is 7. 7 is greater than 5. Therefore, you add a 1 to here. So answer becomes D. So that's pretty simple how you calculate significant digit in measurement. Now measurements have a number and the unit. So we looked at the unit. We are going to look at the unit part of the number. We talked about the number part in the previous slides. The units are used as conversion factors to convert one measurement to another measurement in different units. Conversion factor is a factor that converts one unit to another. Conversion factors are usually written as equalities. So this is 2.1 pound is equal to 1 kilogram. You probably heard about this. 1 kilogram is 2.21 pound. You guys have any questions? So this is a conversion factor. It could be written as equality or fractions. 2.1 pound divided by 1 kilogram or inverse. So this conversion factor here going to be one of these depending on the quantity, units of the quantity to be converted. Factor label method are used for conversion factor to convert quantity in one unit to a quantity in another unit. Units are treated like numbers. Measurements has a number and the unit. Unit also could be treated as numbers. Make sure all unwanted units cancel when you do that. For example, how do you convert 130 pound to kilogram? You write down the 130 and use the conversion factor in a proper form. The conversion factor should have pounds at the bottom of it. So one fraction has pounds in the bottom is this one. That's the one conversion factor we going to use to convert 130 pounds to kilograms. So this is the one we use because these pounds cancel out, not that one. Answer has two significant digits because the number of the significant figure in the measurement we started with has two significant digits. Therefore, this should be rounded off to two significant digits as well. Now remember, these 2.21 and 1 are exact numbers. They are coming from definitions about the conventions. They don't have uncertainty like measurements. Therefore, they are not counted in the figuring out of significant digits in the calculated number. The bottom conversion factor has the original unit in the denominator, pounds. The unwanted units, pound cancels out here and leave the kilogram. Mass and the amount of matter is measured in mass. And weight is also another name we use for amount of matter. Mass is independent of location. Weight depends on the gravity of the location. Gravity is based on spring balances. Anything that uses spring or gravity to measure the mass. So it's called weight. Therefore, mass is the one we use in sciences. Weight depends on the location, depend on the force of gravity at the particular location. Now we're going to talk about unit prefixes. We use unit prefixes. Unit prefixes are letters that G, big M, kilometers, megameters, gigameters, decimeters, to make units larger and smaller. We use exponent value. You start with the bigger units here, 10 to the 9, and go down as the prefixes become pico. That's the smallest meters if you are measuring length. Gigameter is much larger than picometer. So you need to remember these numbers. Milli is 10 to the negative 3. Micro is 10 to the negative 6. nano is 10 to the negative 9, pico is 10 to the negative 12. Which matrix prefixes, metric prefixes, commonly abbreviated using a Greek letter? The one using Greek letter is the micro. You go back and look at it. All except micro are big letters or alphabetical letters. So answer is micro. Use mu. Which of the following is correct order of length? Greater to the smaller. C is the correct answer. Kilometers are bigger than centimeters. Centimeters are bigger than millimeters. Millimeters are bigger than micrometers. Therefore, answer is C. Which of the following is the correct order of length? Now, decreasing these are in the problem 68. They were decreasing masses. In here, these are increasing masses. So you have to find out increasing masses are on the left side. You have to have the bigger mass. So C is the correct answer. Meter is greater than centimeter. Centimeter is greater than micrometer. Micrometer is greater than nanometer. How many millimeters are there in 1 megameter? I'm going to show you how to do this in the next slide. So you write down 1 megameter. You need to convert 1 megameter to millimeters. 1 megameter is 10 to the 6 meters. You use the conversion factor. Convert to meters. Then meters converted to millimeters. Here. 1 meter has 10 to the 3. 1 times 10 to the 3. There's a 1 missing here. So answer becomes 1.9. Now, you have to line up like this. It's very difficult to just guess without writing down. So you get the answer always. You start with the millimeter, 1 need to be converted, 1 megameter. Then go to the meters and meters to millimeters. And the second one, how many are in 1 millimeter? So you start with 1 millimeter. Convert it to the meter. 1 millimeter is 10 to the negative 3 meters. And meters converted to megameters. So 10 to the negative 9. So you get the answer. So this is pretty simple if you follow the procedure. Factor label method using conversion factor. Convert one quantity to quantity in another unit. So we done this. We converted 130 pounds to kilograms. There are a lot of conversion factors. You cannot remember all of them, but common conversion factors like 1 foot is 12 inches. 1 yard is 3 foot. 1 mile is 5,280 feet. Those are common since we use it often, we remember. 1 ton is 2,000 pounds. 1 pound is 16 ounces. That's very common. So metric relationships are the ones which we are not familiar. When you have a conversion to be done, we need to give you the conversion factor, so you can use it in the calculation. You cannot remember most of it, so we will be giving you the conversion factors. Converting pound to grams is this conversion factor. 1 pound is 453.6. Convert 381 grams to pounds. So you line up the calculation based on factor label method. This is called the factor label method. You do the calculation for the number, and we also cancel out the units, and then grams is converted to pounds, just like pounds are converted to kilogram. Now grams are converted to pounds. How you convert 1.844 gallons to milliliters? So you need to know how many gallons are in milliliter or conversion factor. So this is the conversion factor. 1 gallon is 3.785 liters. You convert gallons to liters, then liters to milliliters. So question is how many milliliters? So 1 liter is 1,000 milliliters. Now these conversion factors, numbers in them are exact numbers. Exact numbers are one that don't have any uncertainty. They are coming from definition. Therefore, this is the one used to get the significant digit. There are 4 significant digits. That's decimal place after this 0, make this 0 also significant. 4 significant digits, 4 significant digits here. So we're going to do some calculations. I'm going to go to I'm going to do a couple of them. What is the metric length of 200-yard dash? Metric length is meters. So how do you convert 200 yards to meters? You start with 200 yards. $200 convert to feet. Feet converted to inches. Inches converted to centimeters. Centimeters converted to meters. Then you do the calculation and end up with the correct unit meters, and the number part is calculated. To get the number part, you would multiply these 4 numbers and divide it by every time with this. You don't divide by 1, but you have to, these are all ones. Once you multiply those 4, you get 182. Since this number 200 yard is 3 significant digits, because it's significant, the number answer in meters also has 3 significant digits. Now in this here, 200-meter run in a long distance, 200, 2000 meter, 2000 meter here, converted to feet. So how do you convert it meters to feet? Meters to inches. This is given here, meters to inches, conversion factor. 1 meter is 39.37. Then inches, to 12 inches in a feet. So you get 651. Not 65 rounded out to 6.5, 10 to the 4. This is significant digits are 2 because you started with 200 meters. Anyway, that's how you get it. How you convert 250 yards to meters, then in meters. So you line up yards, convert that to feet, feet to meters, you get the answer. So factor label method is used to calculate certain unit to another. Now we are going to look at temperature. Temperature is important. Temperature is a measure of if an object is cold or hot. We use 3 temperature scales: degree Fahrenheit, degrees Celsius, and Kelvin. So we need to convert unit conversion. We are in the unit conversion. We have to convert Fahrenheit to Celsius, Celsius to Fahrenheit, or Celsius to Kelvin, or Kelvin, Fahrenheit to Kelvin. Normally, those relationships are given here. I'm going to explain how to convert Fahrenheit to Celsius. You start with Celsius, convert it to Fahrenheit. Celsius temperature multiplied by 1.8. That's the scale factor. I'm going to show the where you get 1.8 plus 32. That you had to remember. How do you convert Fahrenheit, Celsius to Fahrenheit? You multiply by 1.8 plus 32. How do you convert Fahrenheit to Celsius? You subtract 32. Whatever you did here last, you do first. Fahrenheit subtracted 32 divided by, because this is multiplied. Kelvin to Celsius to Kelvin, you add 273. Celsius, Kelvin to Celsius is, from Kelvin you subtract 273. So these are explained in terms of temperature scales. 1.8, where you get 1.8 Fahrenheit to Celsius. The scale is 0 to freezing point is, freezing point to boiling point is 100. Fahrenheit scale, 32 to 212, that's 180 division. So 180 divided by 100 is 1.8. That's where we get the multiplication factor when you convert Celsius to Fahrenheit. Remember Celsius to Fahrenheit? Scale factor 1.8 plus 32. So you can look at these things and get enough information to remember the equation, Celsius conversion. What temperature on the Kelvin scale is same as normal body temperature, 98.6. How do you convert Fahrenheit to Kelvin? You have to go to Fahrenheit to Celsius. Fahrenheit, Celsius is 37. 37 plus 273. Let me show you this, my work. 300. You convert it to 37 Fahrenheit to Celsius. Then add the 273, 310. Then you get that answer. Body temperature is 50.0 Fahrenheit. So the equation is 1.8 Celsius to Fahrenheit, Celsius multiplied by 1.8 plus 32, 122. That's the answer. So if you look at these are the problems where we calculate temperature conversions. Do them carefully and you need practice. We're going to talk about a little bit of matter. We're done with measurement. Number part we did, and the unit part, unit conversion. Matter is made out of atoms and molecules, according to our latest models. The matter is made out of atoms, molecules, and ions. Ions are missing. There should be ions. All matter is atoms, molecules, ions. Also, based on the physical properties. Matter has fixed physical properties, are called substances. Have variable physical properties, they are called mixtures. These are basic matter. Elements and compounds are the ones that have fixed physical chemical properties. Mixtures depend on the component. Therefore, physical properties depend on mixtures making up. Mixtures are made from either combining elements or two different elements, or compound and element. They have different physical properties depending on the components of the mixture composition. Heterogeneous mixtures are the ones have uniform distribution in the sample. They are all mixed up. That's the goal. I'm not sure what that is. That's the alloy. Brass atom, copper atom. Copper and zinc called brass. Copper atoms, zinc atoms. This is the gold nugget in water. This is a heterogeneous mixture. There's a lump of one material in there. That's the description of. I'm going to continue from there and put the rest of the material. I will post the video and please come back and watch the whole thing again. Okay? I'm going to stop the class for today. All right. Do you guys have any questions?
No.
All right. I will see you on next Tuesday. All right?
Okay.
Okay. Take care of. Have a great weekend.